Assalamu alaikum everyone, welcome back to mathematics, and we are doing A-level CIS paper for statistics, paper code 9709, variant 52, May June 2025, and we are doing question number 6. Find a number of different ways in which the 10 letters in the word amalgamate can be arranged so that there is an M at the beginning, M at the end, and no A's are together. So first of all, we should be looking for how many letters there are. It is always better to calculate the number of letters by yourself, because sometimes the number of letters given here, they don't account for the repetition. For example, if there are A's for 4 times, they can consider it to be just one letter because it is repeated. So the number of letters are just number of letter A is just 1. So it is always better to calculate by yourself. So let's see, 1 2 3 4 5 6 7 8 9 10. So how many number of letters do we have? How many A's do we have? 1 2 3 4. 4 A's. How many M's do we have? 1 2 M's. Is there any other repetition? No. L G T E. The rest of the letters are L G T E. These are just ones. So this is your like the calculation for your letters. How many letters do you have? Now you could arrange it in a way that M is at the beginning, M is at the end. So how many spaces are left behind? 1 2 3 4 5 6 7 and 8. So we are left with 8 spaces and no A's are together. So it could be like we leave one space for A between the letters. So this is how they want it. But whenever we have to look for no A's are together, or no two people or no two things are together, we took this kind of condition, like you take L, G, T and E. So how many places there could be possible for A's? This space, this space, this space, this space and this space. What do I mean actually? For example, in this combination arrangement also, you could start L, G, T and E like this, then this space will be empty. Okay, so for this reason we use this kind of a method to understand how many available spaces are there for A and how many A's are there. So how could we arrange them? Now the thing is we need to arrange them. Arrange A's. But does order matter here? No. In whatever order A's are arranged, it doesn't matter. So order doesn't matter. Okay. Is the number of spaces equals to the number of things? No. How many spaces do we have? We have 5 spaces and we have 4 A's. If we have number of spaces and number of things equal, then we use the factorial thing, arrangement. Okay, we only use the arrangement thing. But when there are more spaces, or the spaces and the things number don't match, then we use the either combination or permutation. So why we will be using combination is because order doesn't matter. So when order doesn't matter, that means we use combination. We don't use permutation. Okay, so let's do this. For 4 A's, we have 5 spaces and we have to arrange 4 A's into 5 spaces. So 5 spaces and 4 letters. So arrangement will be 5C4. Also for your rest of the letters L, G, T, E, these are 4 things and 4 places for them. So we will be using the factorial thing for L, G, T, E. We will be using 4 factorial. Okay, now how could we write it? The total, like the number of arrangement, and so we have to arrange A's and we have to arrange LGTE. So this will be your total arrangement. So 5C4 is 5 and 4 factorial is 24. So it gives you 120 in total. Okay, now we have, this is part A. Now we have part B. Find the number of different ways in which 10 letters in the word amalgamate can be arranged with exactly 3 letters between the two M's. 3 letters between the two M's. Okay, to understand this, we will be doing a manual thing for this to understand this scenario. So they are saying which 10 letters amalgamate can be arranged 3 letters between two M's. So that means we could have M and we could have M, and there could be 3 spaces, 1, 2, 3. Okay, when we have occupied 5 of the total spaces, how many are left? 5. 1, 2, 3, 4, 5. Now again take, okay, first let's take 10 spaces so that I can arrange it. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, let me just copy this. Okay, M could be here with 3 spaces, 1, 2, 3, and M here. Then M could be here and 3 spaces in between here. Then we can have M could be here with 3 spaces between and M here. Then again we can have an M in the next place and 3 spaces between and then another M. Now M could be here with 3 spaces in between and an M here. M could be here with 3 spaces in between and M. Yeah. Any other possible scenario where there will be 3 spaces between two M's? No, I guess so. This is all. So how many arrangements are these? See, for each one of them, what will be the arrangement for if I take just one of them? This is 2 are fixed, so we'll only consider these 8 spaces. So for these 8 spaces, we have 8 letters, so 8 factorial. Are there any number of repeats? Yes, we have 4 A's, so divided by 4 factorial. So this is for 1. And how many such arrangements are there? We have 1, 2, 3, 4, 5 and 6. So 6 arrangements like this are possible. So multiply it by 6. So when you multiply it by 6, you get 10,080 number of ways this could be arranged. Okay, we are done with part B as well. Now we have to do part C. Now part C says that find the 5 letters are selected from 10 letters. Okay, 5 of the letters are selected. Now find the number of different selections in which 5 letters include at least 1M, 1M, at least. You have to consider also the terminology accurately. At least one. At least one means more than one is possible, but at least one should be there. And at least 2 A's. 2 A's means, at least 2 A's means that there could be more than 2 A's, but at least 2. So this also we have to do manually, like list all the possible arrangements possible and then solve it. So, okay, 5 letter words. So first make 5 spaces, 1, 2, 3, 4, 5. 1M in 2 A's. This is the least possible thing. 1M, 2 A's, then there could be more than 2 A's, so it could be yes 1M and 3 A's, and because we have more, like we have 1M and we could have 4 A's. Okay, then again consider the scenario for at least for 2 M's. There could be 2 M's also, because we have 2 M's. So with 2 M's you can have at least 2 A's, and with 2M you could have 3 A's. Okay, there is not much space, so we can consider any further scenario also. There are only these much spaces, like we have only 5 spaces to deal with. So let's write down the combination for each one of them. Why we are writing combination? Because now we are left with some letters. Spaces are less, but number of letters that are left are more. So how many letters we have taken into account? We have taken into account M's also and A's also. So left ones are L, G, T and E. So in this L, G, T, E we have 4 letters and how many spaces? 2. We have 4 letters and how many spaces? 1. There are 4 letters but 0 space, 4 letters but 1 space, and again 4 letters for 0 space. Okay, so now calculate this, what it is equals to. 4C2 is 6, 4C1 is 4, 4C0 is 1, 4C1 is again 4, and 4C0 is again 1. So when we add these all, so total gives you 6 plus 4 10, 10 plus 1 11, 11 plus 4 15, 15 plus 1 16. So total selections will be 16, because they use the term selected. 5 letters are selected. So how many selections are possible there? 16. I hope you understand this question. Some students find it a bit difficult to solve because there were many things to break down into. So if you understand this, give us a thumbs up. And for any queries, any suggestions, you can write us in the comment box. Thank you.